Hey everyone, my name is Madison Hoffman and this is my video demonstration for Project 3. The goal of this project was to measure and transmit fan speed and thrust. The specific requirements were to basically build an optical tachometer to measure the speed of a brushless propeller, which is driven by an Arduino and measured using an IR emitter detector pair using either round robin with interrupts or function queue scheduling. So I'll just talk about my hardware a little bit, show you my software, and then hopefully show you that this works as expected. So here, I'll just note that different from the requirements, I didn't use the propeller, I couldn't quite get it working, but I have this DC motor and fan in a starter kit that I ordered when I ordered my Uno here. So I'm using this fan rather than the propeller. Since I think the main goal is to measure RPMs. So here on the left, I've set up my IR emitter detector pair. The emitter is the clear and the detector is the black. I've connected him to my Uno, which is powered via my laptop through this USB cord. I've connected the breadboard using the 5-volt power. And then I also have ground going to the board, and then I have attached the emitter to digital pin 13 and the detector to pin 2, and put them facing each other, as you can see. For the detector, I've used a 10K ohm resistor, and for the emitter, I've used a 220 ohm resistor. So for my fan, to get it powered and spinning, I have powered it using this 9-volt battery, which you can see is connected to the board here. And then I'm using this potentiometer here in the middle to control how much power is going to the motor so that I can control the speed of the fan, so that I can just kind of turn it on and off without having to attach and detach the board from the battery. So pretty simple. Hopefully this works. So now looking at my software design, also pretty straightforward. I think the important things to note are here I'm setting up this interrupt on pin 2. It's basically set to trigger on the falling edge of a signal, so whenever there's a gap in the fan blades, and whenever we trigger that interrupt, we call this ISR RPM, and we increment the value for a number of breaks. So the way we use that, so also in the setup method, I just turn the IR LED on so that it's just emitting signals, and I initialize number of breaks and RPMs to 0. So the way we use this interrupt is in this loop method. Each second we disable interrupts, and then we use the current value of number of breaks, and we disable interrupts so that number of breaks doesn't keep changing on us. We use this value to compute the RPMs by taking the 60 seconds per minute, multiplying it by number of breaks, and dividing by the number of blades. When I was trying to use the propeller, that was 2, but using this fan, it's now 3. I then get the value for time, and I print those out to the serial monitor. And then I check to see if it's the end of the program or not, which you can end the program by just entering a $, and then I reset number of breaks and RPMs to 0. And then I re-enable the interrupts. So pretty simple software design. It's a round robin with interrupts. I didn't choose to use function queue scheduling here. But yeah, so hopefully we'll run this and see that it works. Might be a little challenging one-handed, but we'll see what we can do. So here we're starting to print out the time, the RPMs. We can see the RPM is 0, and then this is just elapsed time in seconds since we started the program. Okay, so hopefully we'll turn on the fan and see the value for RPM start to go up. I think max speed is around 5,000, but we'll see. I might not do max so that it's not spinning too fast. So I'll go ahead and turn on the fan by twisting the potentiometer, grab the fan, so it's spinning. It's pretty fast, so hopefully we see something around 5,000. So I'm just gonna put the blades here between the emitter and detector. Looks like we're a little lower powered than normal. I might not have turned it back on, but we can see the RPM starting to come through. So I took it out for a second, and now we're back in. Okay, now we're at around 5,000. And I can remove it. Should drop to 0. Cool. Put the fan blades back between. tachometer back up. So it seems to be working. I'm not holding it very steady, which I think is why these values are all over the place. When I did it earlier, kept it much more regular. And yeah, so that's it. It seems to be working. I seem to have built an optical tachometer for measuring RPMs of a fan. Thank you for watching.